Today we'll be looking at linear inequalities. Our objectives will be to graph linear inequalities and then to graph systems of linear inequalities. So let's begin with our first linear inequality. If I give you y is greater than or equal to 3, if we want to graph that, first of all we need to remember, how do you graph the line y is equal to 3? Well, hopefully you remember that that is a horizontal line located 3 units up the y-axis. So you would begin by graphing that line. And then remember, greater thans are the things that are above, and so on the y-axis the things that are above are up here, and so you'll see that they're shaded. So the graph of the linear inequality y is greater than or equal to 3 is what you see on the screen right here. Now let me go on and clarify one more thing. If this had been y is greater than 3 without the equal to, then this line right here would have been a dashed line. The line itself is not included in the solution if it is a greater than without the equal to. Let's look at another one. What if I gave you x is less than or equal to negative 2? Well, once again, we need to remember, how do we graph the line x is equal to negative 2? Well, hopefully you remember that that is a vertical line located on the x-axis where x is equal to negative 2. So it would look like this. Because we're looking at less than or equal to, then it would be the things that are shaded to the left. That's where things are less than on that x-axis. And also still remember that if there had been no equal to with it right here, then this line would have been a dashed line as well. I do need you to know how to do both of those cases manually, because in a little while we're going to need that. But right now I want to continue on to another linear inequality. And this time we're going to use the calculator. What if I gave you y is greater than or equal to 3x minus 4? Well, you know how to graph the line y is equal to 3x minus 4 on your calculator, so go ahead and do that. Once you've done that, what we'll do next is this. We will back up using your blue arrows to out here in front of your y. So use your blue arrows, back up there, and hit enter until you see the triangle that points to the top right, like the one I have circled on the screen right now. Once you see that, then you can simply hit the graph button, and what your calculator will do is come back and actually shade for you which side of this line needs to be shaded. I do need to make sure that you understand, when we deal with inequalities, we are always dealing with shading. If it's an inequality on a number line, we'll shade either to the left or to the right. If we're doing linear inequalities, then we're talking about a line, but it's still going to be shaded on one side or the other. I always have students who say to me, when do I shade? If you have an inequality, you should be shading. So in this case, the calculator will show you which side should be shaded. Now let me make sure you understand what this says to us. That says that anything that is in this shaded area, for instance that point right there, if I plugged it in to this inequality right here, would make it true. This point right here would also make it true, as would this one. Let me ask you, what about a point that's on the line right there? Because the equal to is with this, the point that is on the line also makes it true. What about this point way over here? Well, you'll notice it's not shaded and it's not on the line, therefore it is not a solution to that inequality. You cannot list all of these points for me, but what you can do is draw me a picture of them, and that's why you shade inequalities like this. Let's look at another one. What if I give you this time y is less than or equal to a negative 2x plus 3? Once again, you know how to draw the line, and this time we're looking for a less than or equal to. So we're going to have our triangle pointing to the bottom left. That's your symbol for less than. So use your blue arrow keys to move out in front of the y, hit enter until you see the lower left triangle, and then you're ready to graph. When you graph, you should see this picture. I want to remind you, we've already talked about how less than or equal to are the things that are below the line, while greater than or equal to's are the things that are above the line. Well, notice, if I take this because it is a less than right here, you could do this easily manually. Here's your line. Where are the things that are below the line? And it's all the stuff down here. Once again, the line is included because it is an equal. If this had only been a less than instead of a less than or equal to, you would have expected this line to have been a dotted line down through here. And then if I said to you, what about this point on the line here? Then your answer would be that is not part of the solution. If it's an equal to, the line is part of the solution. If it is not an equal to, then the line itself is not part of the solution. Now let's look at graphing a system of linear inequalities, also using the calculator. If it's going to be a system, I need to give you two of them, so here is your system of inequalities. Go ahead and enter those in your calculator, the negative 2x plus 3 and the negative 2 divided by 3x minus 4. Also, go ahead and enter out in front your symbols for your less than and greater than. Notice that the top one has the triangle pointing down to the left, and the bottom one has the triangle pointing up and to the right. Also notice that there is no difference in what you enter, whether the equal is there or not. You have to realize whether these lines are dotted or solid. Once you've done that and you hit graph, what you should see is a picture that looks like this. Now let me make this very clear to you. Things that are double shaded are the things that are your solutions to the system of inequalities. So if I ask you, is this point right here a solution to the system? Your answer is yes. Things over here are solutions to only one of the inequalities. Things over here are solutions to the other inequality. And things over here that are not shaded at all will not make either of the inequalities true. But in this case, it's the things that are double shaded that you're looking for your solution. I also need to make sure you understand this line has an equal to, which means that this line right here is indeed a solid line, and I know it's that one because I'm looking at the y-intercept and it crosses right here at y is equal to 3, so I know that's the top line. This line here does not have an equal to with it, and so technically it is a dashed line. So let me ask you these questions. Is this a solution to the system of inequalities? Yes, it is. Is this a solution to the system of inequalities? Yes, it is. Is this a solution? And the answer is no, it's not, because that line is a dotted line, meaning it is not included. Let's look at one more system of linear inequalities. This time, our system has 4, and we've never dealt with a system that has that many steps to it, but you're going to find that the steps are the same as what you've already done. First, we'll want to enter these two on your calculator just like we did. And as a matter of fact, these are the same two lines you had a minute ago. So let me go on and bring that picture up. Now what we're going to do is we're going to put these two in by hand. That's why I said when we started those first ones, you're going to need to know how to do these. Y is less than or equal to 0. We want to do that by hand. Well, where is the line y is equal to 0? Well, it's the line that is actually the x-axis right there. Y is equal to 0. And we want the things that are less than that. Well, where are they? They're the ones that are below. I also want to do the line x is greater than or equal to 0. Well, the line x is equal to 0 is right there. So where are the things that are greater than? Well, they're the things that would be shaded this direction. Now, how does that impact our solution to the system of these inequalities? I only want the things that are shaded all 4 ways. So this part up here is no longer going to be part of our answer. It's not a part of the solution. It's not shaded with this line, as a matter of fact, or with this line. What about this piece over here? It's not either. The things that are still included were the things that are double shaded here, and now the ones that are shaded down, so we get this part here, and to the right. So your area this time is actually this line right here, which is a solid line, this line right here, which is solid, this line is solid, and this line is a dotted line. And it's all of the things in between there is your solution to this system of inequalities. Let me ask you this question. Is this point right here a solution to the system? No, it's not. Neither is this, nor this. What about this? The answer is yes, it is, because it's on the line. What about this? Yes, it is, because it's on the line. What about this? It is not, because that line happens to be a dotted line. So it's all of this stuff here, including the lines, with the exception of that side, which does not include the line. I really don't think that these are that difficult if you'll get used to using your calculator to do them. That's all I have for you for linear inequalities. Have a great rest of the day, and I'll see you again soon. Bye-bye.